All right, so let's continue. All right, so like I said, geometry will involve you using a little bit of algebra, okay? Because it's going to involve finding unknown angles. And when it comes to finding unknowns, okay, you have to use algebra because you use equations to find the unknowns. Now, an equation is basically something like this: 2 plus x equals 30, for example. That's an equation. Okay, and you'll be using this, okay, to figure out unknown angles. So our intention today is to solve equations, so linear, very simple, basic equations to find unknown values of the angles. So we're going to try and find unknown values of angles. That's the main thing that we're going to try and learn about today. And hopefully by the end of today's lesson, okay, you'll be able to express a geometric problem algebraically. So use algebra basically to find unknown angles, okay? And you can use algebra to solve different problems that involve in geometry, okay? So these are the two things that hopefully you guys will be able to do and successfully do for your exams and your SACs. So here's an example of an equation, okay? And this is what it looks like. And there's different parts to it, okay, of your equations. So when it comes to equations, a couple of things that you want to look out for is it needs to have an equal sign. Okay? Equations equal. It's got to have an equal sign. It's also got to have a variable or a pronumeral or an unknown number. Okay, so you've got to have an equal sign and an unknown number of some sort. Okay? When it comes to equations, those are two things you've got to have. Another thing that you need to know is when it comes to equations, you have to know how to rearrange. Now, rearranging just means to move around. Okay? That's another word for rearranging. You just got to move around certain numbers. Okay? That's what rearranging means. And the idea behind moving around the numbers is you want to try and isolate it. Okay, see, the idea is you want to try and make the unknown number, this guy, you want to make it by itself. That's what it means to rearrange and to solve an equation. So there's a couple of things I said there. Equation looks like this. It's got to have an equal sign, some sort of unknown. Okay, and you need to be able to rearrange so move it around so that the unknown is by itself. That's what we're trying to aim for. Okay, we're trying to isolate it, make it by itself. Right, so when it comes to rearranging, you need to know your inverse. Another key word there. Inverse just means the opposite. Okay, the opposite. So say for example, the opposite of left is good. The opposite of up is down. The opposite of plus, minus or negative. Okay, so when it comes to opposites for your rearranging, you need to know what the opposites of certain values are. Okay, so an operator is basically just your plus, minus, times, divide. Okay, that's what an operator is. So if you have, if you have plus or positive as your operator, its inverse or its opposite is negative, minus. Okay, we all know that. Okay, if you have minus or takeaway as your operator, okay, what is its inverse? Amen. What's the opposite of minus? Plus, good, or addition. Okay. What about for multiply? Divide. Okay, that's very bad. Multiply. Let's fix that. So divide. Remember, you can write division in two different ways. Yeah. Why is this lagging? Oh, oops, sorry. Okay. You can write divide as either this, or it could also be as a fraction. Yeah. It looks like minus there. So I'm just going to make that like this. Okay, or you can do divide as that. Okay, and obviously the opposite of divide, or this one, is going to be multiply. Okay, so just understand inverse. If you have plus, when you move it to the other side or rearrange, it becomes minus. When you have minus and you rearrange it, it becomes plus. When you have multiply and you rearrange that, it becomes divide. And if you have divide and you rearrange that, it becomes multiply. Okay, so these are your basics for your inverse. Okay, let's look at some examples here. So if I want to figure out what x is, okay, this one here, x plus 90 equals 180. Okay, I have to isolate, rearrange it, make x by itself. So if you have a look at this equation, guys, what should I move to make x on its own? What should I move? I want to make x by itself. Good, the plus 90, yeah? So you've got to get rid of that plus 90. Getting rid of that plus 90, if you look at the example, what they've done is to get rid of the plus 90, they've made it into a minus 90. And what they've done is they've put that over here. So when you move that plus 90 and you bring it to the other side, it becomes a minus 90. Okay, so that's how I think of doing these equations. Okay, so doing that, 90 minus 90 gets rid of it, so it's gone now, and you've just got this. So 180 take away 90, and the answer is 90. Okay, nice and easy. Yeah? Alright, see if you guys can do this on your own, rearranging this one. So I want you to make x by itself. What are you going to move here to make x on its own? So you've got to rearrange it, make x by itself, or isolate x. Okay, so that's a minus 10. So if you move it on the other side, what does it become? Alright, so solve that for me. Okay, solve that equation for me. Right there. Right, so if you're up to finishing it off, you can check the solutions here. So if you want to make x by itself, what you do here is isolate that x, okay, by removing this. It's a negative 10. So if I move that and I bring it to the other side, it's a minus 10. You bring it here, it becomes plus 10. Okay, so therefore x must equal 90 plus 10, which equals 100. Okay, nice and easy. Did everyone else get 100?
Yes.
Good, good. Okay, let's try another example. Here you have 4x equals 360. Okay, so if you want to isolate that x, you have to get rid of that 4. Now this is a 4 times x. The opposite of times is divide. So what they've done is they've divided the 4. That's gone now, and they've brought it here. So 360 divided by 4 equals 90. Okay, I'll do another example really quickly here. So you might have like 2x equals 10. Okay, so this is 2 times x. I want to isolate the x, so make x by itself. So in order to do that, I have to move that 2. This is a times 2. So if I get rid of it, it becomes divided by 2. Okay, therefore x is equal to 5. Okay, easy. See if you can do it with this one. So this is a 6x, 6 times x equals 54. So you want to isolate the x, make it by itself. So what does x equal? Okay, what does the x equal? Give me a second to do that.
9.
Okay. Alright, so if you're following along with me, let's do the solutions here. So this is 6 times x. Okay, which means that if it's x that you want to isolate, you've got to get rid of that 6. So So it's a times by 6 when you divide, when you get rid of it or you rearrange it. So that's a times. Here it becomes divide by 6. Okay, so that means 54 divided by 6 equals 9. So x equals 9. Easy. Okay, this one here now encompasses two parts. You've got an x here, 2x plus 120 equals 180. So when you get a question like this, okay, this will take a little bit more effort for you to do. Okay, but if you look at the example of what they've done, first things first is they've gotten rid of that 120. So they got the 120 to plus, and now it's become a minus. Okay, so that's gone now. No more 120. And you're left with 180 equals 120. So when you solve that, you're left with them 2x equals 60. Okay, and then from there, this is 2 times x. So if you want to get rid of the 2, it's times, becomes a divide. Okay, so it becomes 2 divided by the 60 divided by the 2, which is what they have here, and that leaves them with 30. Okay. Might do another one, just so people get it, and then you can do that question there. Let's see. So put in a page after this. Okay, so let's say my equation is 6x plus 20 equals, we'll go with 70. Oh no, so we'll go with 80. Okay, 6x plus 20 equals 80. So to solve this, get rid of this plus first, plus 20. Okay, so that's a plus 20. Here it becomes minus 20. So you're left with 6x equals 80 minus 20 is 60. Now you have 6 times x. Okay, it's times 6. So if you want to isolate that or get rid of it, it becomes divide by 6. So x therefore is 60 divided by 6 is 10. Okay, so let's go back here, solve this one for me. Okay, see if you can do that one. Solve that one for us. So get rid of that 57, or that minus 57 first, and then do the 3 after for these questions. So it's a minus 57, and you move it to the other side, it becomes something else. Alright, let's quickly do this and then we'll move on. So, this is 3x minus 57. What you want to get rid of first is that minus 57. So, if it's minus 57, here it becomes plus 57. So, you're left with 3x equals 33 plus 57 equals 90. Okay, now you have the 3x. Okay, to get rid of that 3, it's times 3. Here it becomes divide by 3. Okay, so x equals 30. Did everyone else get 30? Cool. Alright, so this is some basic algebra principles that you need to know for geometry, because there will be a lot of angles and unknowns that you do need to find. Okay. Alright, so a couple of things that you need to know. Also, were people still copying? You need to copy it. Alright, so a couple of things you need to know is algebra. Okay, involves a lot of geometry and unknown angles. Okay, but it's also geometry involves this, but it's not all just this. Okay, there's a little bit more to it than just that. Right, so for the main things that we need to know today is you're going to find angles at certain points, angles based on your parallel lines, angles of triangles, types of triangles, polygons, and exterior angles. So these are the 6 things that we'll quickly try and smash through today. Alright, let's go through it. So angles at a point. When you're looking for an angle at a point, all that's saying is find an unknown angle at a specific spot. Okay, depending on the angle that you're looking for. Okay. Generally, when it comes to geometry, you can't just give the angles as well. Okay, you can't just say, oh, this is the answer. Okay, you have to give us a reason why that is the answer. So in year 11 and year 12, when you do geometry, you have to give them a reason for why the angle equals that. Okay, and here in geometry for year 10, we're going to learn about 4 reasons why certain angles are the way they are. First reason is a complementary angle. So when an angle should equal 90, okay, we use complementary as a reason for it. Okay, so if you say the angle for, let's say this is, I don't know, 70, okay, angle B should be 20, okay, it's 20 degrees because they are complementary. Okay, so you have to use this word as a reason for why it is that angle. The other one is supplementary. So if your angles will equal 180, then it is a supplementary. Okay, you have to use the word supplementary as your reason for why it's 180. If your angles are a revolution, that means revolution just means 360. So if your angles equal up to 360, then the reason is revolution. Okay, so I'll quickly use that as an example. Let's say that this angle here is, I don't know, 250. Okay, actually that won't make sense. Okay, let's say that this angle here is 200 and let's go 290. Okay. Right, so that means if it's a revolution, it should equal 360. So if I asked you, Abby Schaefer, what would angle A be? If technically this should all equal 360, and that's already 290, what would this angle be? Good, 70. So if angle A is 70, the reason is it's a revolution. And that's what you would say. Okay, because this whole thing should equal 360. Okay. And vertically opposite angles. So generally this is when you come across a shape that looks like this. Okay, if you look at this, A and B are exactly the same. Okay, and you use this vertically opposite because if you look opposite of that angle, they're exactly the same. Okay, so those are the 4 reasons we're going to use, okay, to justify why a certain angle is what it is. Okay, so you have complementary 90 degrees, supplementary 180, revolution 360, and then vertically opposite is on the other side or opposite side of that angle. It's exactly the same. Okay, so let's do some of these. And then I've got the reasons up here for you guys too, so you've got the same, so you have it there. So we're going to try and figure out what these angles are. Okay. So let's start with, okay, let's go with question A. Okay, we have to figure out what angle A and B are on this. Okay. Now, let's see. What can we see here already that we can use? Anyone know? Which angle do you want to start with? A or B?
A.
A. Okay, let's start with A. I can see that angle A here, okay, and angle 70, these 2 angles should technically equal up to what? 180. Okay, so that means if I go A plus 70, it should equal 180. Okay, so solving this, guys, what do I have to do? How do you solve this? Take away the 70. Good. So take away the 70. Therefore, angle A is equal to 110. And the reason behind that is because they equal up to 180. In brackets, you'd write supplementary. Okay, so you have to give us a reason why it equals 110. Supplementary, and that's because we use the fact that it equals 180. Okay, so if I get rid of this. Alright, so I've done that. Alright, what about for angle B? What can I do? So I already know that this is 180, just keep that in mind. I'll say 110. Okay. So what can we do for angle B? You have 2 options. Okay, for reasonings here. Anyone want to point them out what the two options might be? Yeah, what are the two options? So what can you say about angle B and what it might be? There's two ways you can find what angle B is. Yep.
One maybe because it's opposite.
Good, so Abby's saying one is that B is opposite 70, so you can actually reason and say, because that's 70, okay, that means B must also be the same. So it's vertically opposite. Okay, that's one way. I'll write that down here. B should equal 70. Okay, and you don't need to show working out, because you can just look at it and say, oh, that's vertically opposite to that. Okay, so you can write that down. Okay, and then what's the other reason? What's the other way you can find it? Yep. Maybe again.
Instead of using the line that's this way to 70 is you use the other line.
This one, yeah?
We already got 110.
Good. So we know that angle A and angle B. Angle A is 110. So if you go 110 plus the B, it should equal. And how much should that equal? Look at this angle here. 180. Okay, it should equal 180. So using algebra, that's a 110. It's a positive. It's a plus. So if you move it to the other side, okay, it becomes minus. Okay, that means B should equal 70. And the reason behind that is because it equals A and B. These two angles are 180. It is a supplementary. So you put that in brackets. Now, you don't have to show both of them. Okay, at least one of the options is fine. And you don't have to technically show all of it. Cool. All right, next one. This one here, B. You've got angle A that we're looking for. You have this angle that's 130. Anyone know what this angle means? 90. That's a 90-degree angle. Okay. So I can say that this whole thing makes a circle there. So if you have a circle, what does that equal, guys? 360. So what this is saying is, if you add all of these, it'll equal 360. So that means algebraically you'll write A plus 90 plus the 130 equals 360. Okay. Now we've never come across an equation that looks like this, but does anyone know what they need to do now? What can you do? So I say that again. It is revolution, that's correct. But how do I solve this? I now have to
take away 90 and take away 130.
Good. Yeah, take away 90, take away 130. Okay. So if you do that, take away the 90, take away the 130. Okay, that will give you the angle for A. So in this case, that would be 120, so 140. Okay, so the angle for A is 140. Okay, and the reason behind it is, as Shia said, revolution. So you would write the reason why, because it's a revolution. Okay, because it equals 360 initially. All right, last one for this. Okay, I can see that this is a 90-degree angle. So already you could probably already tell what's the reasoning for this. It's going to be the complementary because it should equal 90. Okay, so that means if you have A plus this angle of 71, it should equal 90. Okay, and then just solving that, nice and easy. 71, 90 minus 71. Yeah, good, thank you. So minus 71. So that means the angle for A is equal to 19. Okay, and as I mentioned before, because it equals 90 degrees, the reasoning behind it is complementary. So you'd write in brackets, complementary. Okay, so this is what you need to do when you have to have reasons for why certain angles are the way they are. You can't just give us an answer. Okay, these questions here will count for 2 marks. One for the answer, one for the reasoning. Okay, so you've got to make sure you have both when you do these questions. All right, any questions about that? Okay, everyone sure, or anyone not sure about it? Okay, let's keep going. I think we've got a few more to go for this. Alright, so now that we've got reasons, okay, for finding angles at a point, now we have to also have reasons for finding angles when you have your parallel lines. So a few things to think about here. There's more reasons that you've got to know. Okay, parallel lines are basically when two lines are directly straight and they'll never touch each other. Okay, so they're not at an angle or anything, just straight lines. Okay, so I can see here alternate angles corresponding and co-interior. 3 reasons. Okay, let me explain them. An alternate angle, right here, is basically when you have an angle that's the same as an angle on the other side. So generally you'll find a question where you have 2 parallel lines and you have this thing called a transversal. Just think of them as sort of like a split between the 2. Okay, so they all have transversals. An alternate angle is when an angle on one side of the transversal is the same as an angle on the other side. It looks like this. So if you look at a Z, I always sort of look at it as like a Z point, like that. And at a Z, you'll find that this part of the Z and that part of the Z are actually the same. Okay, if they're parallel. And you know that a line is parallel when you see these little arrows. Okay, so just remember those little arrows to prove that something is parallel. So alternate just means angle on one side of the transversal, so that is the same as that. Okay, you'll also see this happening. Let me get rid of this. Okay, you'll find that there's also a few alternate angles in here. This angle, and this angle are also alternate angles. Okay, they're the same, just on the opposite sides of that transversal line. Okay, exactly the same. So that's one reason for when you're trying to prove whether why an angle is what it is. The other reason is corresponding. So if something is corresponding, that means if you look at the line, okay, you've got an angle, okay, there, that's the same with another angle on the same side of the line this time. See, there's the line. There, so we're looking at this half, this angle and that angle are exactly the same. Okay, you can also justify and say that this angle and this angle are also the same on that transversal. Okay, so corresponding just means they're both the same, but on the same side of that transversal. Okay, and I think it'll make more sense when we do examples on it. Last one is co-interior. Okay, so co-interior is just saying if you look at the shape like this and you look at the inside, okay, this angle and that angle will always equal 180. Always. Okay, so if you look at this shape here, inside, co-interior, always think of interior as inside. So the inside, so this is also an interior, but we're looking at this co-interior here. So co-interior angles always equal 180 degrees. Okay, right there. Alright, let's just do examples so we can get a hang of what this is. And then I think I might stop here so you guys can start doing some work. Right, so let's solve the values of these angles and then we need to provide reasons as to why they are whatever the angles are. Okay? So let's look at angle A. Alright, yeah, A. And looking at angle A, I can see that you've got 74AB and then an unknown angle here. I can also see that these lines are all parallel. Okay, now looking at this, I can see that there's 2 ways I can figure out what A might be. Okay, but the most obvious one is what I'll use for now. I can see that's 74. Okay, and this is actually a co-interior angle. So what that means is A plus 74, if it's co-interior, it should equal 180 degrees. Okay, it should. Which it does, because looking at the previous example here, remember these angles, this and this, should equal 180. So logically, this angle and that angle should also equal 180. So solving this, take away 74, Therefore, the angle A is 106. And my reasoning for that is that it is co-interior. Okay, it's a co-interior angle. It's not double R, sorry, it's one R.
Yeah, he's about to like the top turn.
Is it one R or two R's? I think it's one R.
One off.
Okay,
Okay.
yeah, sorry. I'm not an English teacher. Oops. Okay, co-interior, so you have to provide the reason for it, okay? Now, angle B, let's look at that. Okay, looking at angle B, remember this is 106. Okay, that's 106 degrees. So similar principle, co-interior, if you look at it, there and there, these should also equal 180. Okay, so 106, or if you go B plus the 106, it should equal 180 degrees. Okay, so working that out, that's a plus, so it becomes minus here. So therefore B is equal to 74. Okay, and I know that that's co-interior as well. Okay, so in brackets, co-interior. Okay, so make sure you put your reasons down, or else you only get half a mark. Alright, B, this question here. Alright, I can see I've got two angles that I'm looking for again. Okay, looking for angle A and angle B. We don't have to look for the angles in order. Okay, you can start at angle A or B, it's up to you. I might start at angle B for this one. Okay, just to spice things up a bit. Now, if you have a look at this, okay, this angle here, what should it equal altogether?
90.
90, okay? Always has to equal 90, okay? So I might write 73 plus B, what does that equal? It should equal 90, sorry. Okay, now have a think. We've got these reasons, but all the previous reasons that we had. Does anyone remember, okay, what did we use to prove that something was 90? Starting with C, complementary. Okay, just double check that that is the right word. Yes, supplementary is 180. Okay, so complementary. So that means if you're trying to figuring out B, so you minus that 73, B equals 17. Okay, and we know that it's complementary. So notice how I didn't just use these ones, I also used the previous ones to prove that the angle is what it is. Okay, now I'm going to be a bit tricky here as well and say, okay, if this angle here is 17, okay, what should this angle be? A. 17 as well. And what's the reasoning for that? Well, if you have a look, okay, looking at this angle, or actually, picture again, that's the best one. Yeah. Okay, so if you have a look at this diagram, this angle and this angle, okay, are the same. So the reasoning for that is it's alternate. Therefore, if you look at this angle here, okay, right there, is actually the same as this angle here as well. And they are alternate angles. So that's one way I could reason with it. So I'll write here, B, so A is equal to 17, which is what B was. And the reasoning I got for that is that angle and that angle actually alternates. I'll use another color so it's not confusing. A equals 17. Okay, and the reasoning I'll use is alternate. You can actually go ahead and use other reasons if you want. Okay, but actually no, actually for this one there isn't. You can only use that. But you can say that if that's 73, that should also be 73, and then you can go ahead and do complementary again. But I think it's easier to just say that angle must be the same because they are alternates. Alright, last one, and then you guys can start working. Alright, this one here is a little bit trickier, but again, watch out for the parallel lines. These lines should be parallel because they're actually the same length. Okay, now, according to this is a 90-degree angle. What do we see on the opposite of that? A. So remember what the reasoning for that is if you have an angle that is vertically opposite, it should be the same. So I can start off with that and say that A equals 90. And that's because this angle and that angle are vertically opposite. Okay? So if that's 90 degrees, okay, have a think. 30, 90. Now this we haven't gone through yet, but this is actually a triangle. Can you guys see that? What should triangles equal to, angle-wise?
180.
180. Okay, so if you actually went 30 plus 90 plus B, it should equal 180. Now, if an angle equals 180, okay, we use supplementary, okay, to figure that out. Just another look. Okay, so we know that that equals 180. So working this out, to get rid of that, to make B by itself, minus the 30, minus the 90. Okay, so that means B should be, what's that, 120, so 60. Okay, and this is supplementary. Okay, I'm going to stop there. Okay. Does that make sense? So these are three types of triangles. Scalene, all different. Isosceles, two are the same. Equilateral, all three are the same. Right? Alright, so let's look at these triangles. Okay, and then we're going to provide reasons. Okay, and we're going to use these reasons again. Okay, you don't necessarily have to use these reasons. These are just different types, but we're going to use all these reasons to figure out why the angle is what it is. Okay, so let's look at this. For example, 152 degrees here. We're going to start with y. That angle there, okay, all the way here should equal 180. Okay, so 152, and that's y. Okay, so that means y plus 152 must equal 180 degrees. Okay, and I'm going to use my supplementary as a way to prove that this is 180. Oh, well, to prove that this is what the angle is. So that's plus 152. Get rid of it, becomes minus 152. Therefore, y equals 28. Okay, so that means that angle, y equals 28, and the reason I use will be supplementary. Okay, so it's supplementary. Next is x. Okay, x for this angle, you don't have to provide a reason, just tell me what it is. Okay, because it's a isosceles, it's a scalene triangle, none of them are going to be the same. So you don't have to necessarily write the triangle is scalene. Okay, just tell me what x is in this case. But understand and remember that y here is 28. If that's 28, that means if you put it all together, x plus 80 plus 28 should equal 180. And I wrote it's 180 because it's a triangle. Okay, so any triangle must equal 180 degrees. Okay, so this one here, it's they're all pluses, so it's going to be x, get rid of that 80, it becomes minus 80. Get rid of that 28, it becomes minus 28. X equals 180, take away 80, take away 28, which equals 72. Okay, so that means x equals 72. You don't need to provide a reason, it should be okay for those ones. Right? Easy? Yeah? Next one, we have 38, we have y, we have x. Okay? Let's start with y. Okay? This is a triangle right here. You see that? Okay, so that means all of those angles, when you add them together, should equal 180. Who's ready for that? Okay, so this, work with me. This is a triangle, and I know that y plus 38 plus 18 should equal 180. Okay, So in that case, isolate the y. So that's minus 38 minus 18. So y equals, well, I'll do that in my head too much. So use your calculators for this 180. Take away. Take away the 38.
It's 124, sir.
124. I'll clarify that. Thank you, Lily. 124. Okay, so that means y is 124. Easy. So this angle right here, 1, 2, 4. Okay, nice. Now I have to provide reasoning here. Okay, so for this one, this angle 124 plus that x angle there should equal 180. So 124 plus that x, which is that angle here, should equal 180. Okay. Now in that case, that's plus 124, so minus it here. 4. X should be 56. Okay, so that angle x is 56, and we know that it is again supplementary angle. So put your reasoning there for it. Okay. So just put your reasonings in the brackets. That should mostly be enough. Yes, Nazmi. You can technically, guys, you can technically do that too. If you just show some form of working out with your reasoning, then you'll get them up. Okay. All right, let's move on. All right, these ones. Okay, you're probably going to be using some of these now for finding these angles. All right, so solve for the numerals, providing reasons. Now, having a think about some of how these angles will work. Okay, you've got parallel lines here, and apparently these two lines are the same. Now I can see in this triangle, okay, there's something interesting about it. Okay, two sides are the same, which means it's an isosceles triangle. So if it's an isosceles triangle, okay, that means two equal sides, two equal angles. Okay, so that means these two angles must be the same. Okay, how do you find out what they are? All right. So for this angle x, if you have a look at this line here, they're both parallel lines. And if you have a look at this angle, can anyone see what's interesting about this angle, 38? Yeah, there's something, it's got something to do with this angle. They are the same. Okay, why are they the same? Anyone know why? What reasoning can I use for that? Anyone know? Two parallel lines here. Okay, and you've got your transversal line right here. Okay. Okay, so there's two parallel lines, there's a transversal. Okay, what do we notice what do we notice that's interesting? Okay, something about this angle, okay, and then another, I was pointing at the wrong angle, sorry. So if that's 38, what would this angle be? Also 38, okay, because it's what you'd call a alternate. Okay, so if that's 38, these two angles have to be the same, yeah? It's a scaling, it's an isosceles, it means there's two angles, okay, that are the same. So that means two of these x's, now we haven't really done this, okay, but 2x plus that 38 should equal 180. Okay, where did I get the 2x from? Well, there's two x's here, add that with this 38, and this triangle, looks a bit messy now, I'm sorry for that. Okay, but this triangle should equal 180 degrees, as we know. Oh. Okay, this guy right here should equal 180. So that means two of these x's plus that 38 should equal 180. Now working that out, okay, that should be minus 38. So x is equal to so far 142. Okay, so far 142. Oh, sorry, 2x, my bad, equals 142. That's 2 times x, get rid of that, it's a times 2, so here it becomes divided by 2, or you can do divided by 2, whichever one works for you, but don't do both of those, because they'll be wrong. So divided by 2, therefore, x must equal 71. Okay, so these two angles are 71. In terms of reasoning, you can say that this angle here is an alternate, but technically you don't have to write anything now. If you want to, you can write these are isosceles triangles, but it's fine. Alright, last one. These angles here. Okay, what do we see that's interesting about this triangle? All equal, so if everything is equal, remember, if it's all equal, all the angles are always going to be 60. Okay, so I'll write here, the angle for y, I know, is going to be 60. Okay, that's fine. X, okay, now that's a bit tricky, but having a look at the fact that these are parallel, and you've got a line here, that means x must also be 60, because, fix that up. If you have a look at the way that the lines work, that line, this angle, 60, is actually the same as this angle, 60. So as a reasoning, you could say that that's actually alternate.
Could you also do it from that line in the middle?
This one here?
Yeah.
Yes. Technically, you could. Okay. Alright, I think there's one more after this. Oh, okay, polygons. What's the time? 1:30. Alright. Alright, we're nearly done, guys. So I think after this, it'll be it. Right, so polygons, just a couple of things you need to know. A polygon is basically a shape with multiple numbers of sides, at least more than 3. Okay, has to be 3, so 3 or more. Okay, any polygon will be any shape that has multiple sides, has to be at least 3 or more. Okay, so triangles are actually polygons. Squares are polygons. Okay, but it's just an overall name that you give for any shape that's got 3 or more. So polygons, this is the rule that you'll normally use, okay, for finding the total angle of a polygon. Let's say, for example, you wanted to know the total angle for a pentagon. It's going to be 180 times the number of sides minus 2. If you wanted to do so in that case, for a polygon of a pentagon, so the total angle for this would be 180 times 5 minus 2. Okay? In that case, it'd be 180 times 3, which is 540. So if you had to use algebra and figure that out, and you had certain sides, okay, you would use this formula to find the total angle for any polygon. So if it's an octagon, it'd be 180 times 8 minus 2. If it was nonagon, it'd be 180 times 9 minus 2. Okay? Alright, shh, boys. Alright, so just some things to think about with that. Now, regular polygons all have equal sides. Normal polygons won't. Okay, so keep that in mind. Regular just means everything's equal. But normal polygons, normally you might have a shape like this. Okay, none of the sides are equal, or you could have a shape like this. Okay, which is what you normally will be working with. Okay. Exterior angles, so some things to think about. An exterior angle here, plus the interior angle, always equal 180, which we've already done a few of. Okay, so that'll always equal 180. Okay, exterior angles on the outside. Yep. Okay. Shh. 7 minutes. Alright.
Okay.
Cool. Nearly there, guys. Nearly done. Alright, so let's try and figure out some of these angles. Alright, so this polygon here has 4 sides. So if you wanted to find the total angle for it, you would go 180 times, it's got 4 take away 2. So remember the formula was 180 times number of sides take away 2. In this case, it's got 4 sides. So that means the total angle here is 180 times 2, which equals 360. That means the total angle here for now is 360, that you know. So which means that if you go 130 plus 90 plus 90 plus x, it should equal 360. So 130 plus the two 90s here, 90, 90, plus that unknown x should all equal 360. Okay, so from there, isolate the x by going, all of these become minuses. Okay, so it's going to be 360, take away 130, take away 90, take away 90. Therefore, the angle x is, what's that, 180, 18 plus that, 50. Yeah, 50. Yep, should be 50 degrees. Okay. This one here. Okay, a bit trickier. It has 5 sides. So first of all, find the total angle. So it's going to be 180 times number of sides is 5. Take away 2. Therefore, it's going to be 180 times 3, which equals 540. So when you add all these up, it should equal 540. So that's going to be x plus 95 plus 120 plus 90 plus 110 equals 540. Okay. Now, if you wanted to, technically, in the way that you normally should do these questions, is you actually want to start off by putting these together before you do anything. Okay, and I haven't really taught you guys that, but algebraically, that's what you'd normally do. So when you add them all, it's going to be x plus, that would be, putting that together, 95 plus 120 plus 90 plus 110, thank you. Okay, so all that together equals 415. Equals 540. And then from there you would start isolating the x. So that's plus 415. Take it away. That makes it easier, doesn't it? So x, so this angle here is equal to 125. Okay, and I think that might be it. There's one more slide. It's that one. Okay, I think we'll leave that for next lesson. Okay. Any questions? Any questions? All right, we're going to stop there.